Fordham here. Graphing quadratics, part 2. And just a quick review. Any polynomial is a quadratic if it has a degree of 2. So looking at these blue examples here, x squared minus 3, the biggest exponent we have is 2, so that would count. This would be considered a quadratic. Over here, negative y squared. Doesn't matter that we're using a y. The only rule is it's got to be degree 2, so this qualifies. Over here we have h cubed plus h squared minus 1. Well, it's because of this h cubed, the degree is 3. So this is a non-example of a quadratic. That would not be a quadratic. And the fourth example, it doesn't matter that it's out of order here. I could have rewritten the terms as negative 4b squared plus 3b plus 2. Either way, it's still a quadratic because the highest degree is 2. It's the biggest exponent. All right, let's take a look at some tougher examples to graph. The last time we looked at some very simple and basic ones, so let's challenge ourselves a little bit right now. So in the first example, we have y equals x squared plus x plus 1. And like before, I'm going to go ahead and use some pretty easy numbers to work with to give us a start. So what I'm going to do is start off with negative 2 and plug it in for each value of x I see. That will give me hopefully the y point. So here we go. Y equals, I use parentheses when I substitute. I just find it's a lot easier. I don't make as many mistakes with negatives. Just makes my work cleaner. Negative 2 squared, well, negative 2 times negative 2 becomes positive, and 2 times 2 is 4, plus negative, so that's really a minus 2, and plus 1. And when we clean all this up, we're going to go ahead, 4 minus 2 is 2, but plus 1 is 3. So we get our first value that we can plug in, and we can go ahead and plot it. So negative 2, 3. All right, now we're going to have to do this 4 more times. Man, only if there was a way to do this in the calculator. God, maybe some foreshadowing there. So here we go. Y equals, again, I use parentheses when substituting. It just makes my life easier. And if we clean all this up, negative 1 squared, that's negative 1 times negative 1, which is just 1, but minus 1, but plus 1. Well, fortunately, when that all cleans up, it just becomes 1. So we can go ahead and plug in a 1 value there. All right, we got a couple more values to check. 0. This is why I love working with 0. It's easily the easiest value to plug in. 0 squared. Man, I wonder what that's going to be. Plus 0. I wonder if that does anything. So I get 0 plus 1. And when I clean that up, the answer is 1. Huh, weird. It's like the value I had before in the other problem. All right, let's go ahead and take a look at now 1. So y equals, I'm going to do 1 squared plus 1 plus another 1. I'm going to clean that up. 1 squared is still 1 plus 1 plus 1, which equals 3. So my values are changing a bit now. But if you notice, if I go back to the table real quick, some of the values are repeating. And that's not without coincidence. Let's go ahead and find our last value where we need to plug in 2. So y equals, let's go ahead and do 2 squared plus 2 plus 1. And when we clean that up, should get 4 plus 2 plus 1. And that is going to be 7. Now that goes off our graph, but we can work with that. It's not too big of a deal. So we fill in our last value, 7 over here. And I'm actually going to go ahead and go back and plot our table. So negative 1, 1 is a value. 0, 1 is a value. 1, 3 is a value. And 2, 7, let's see, 4, 5, 6. It's probably going to be somewhere up there. When I connect the dots, it looks something like that. So it kind of looks like a weird check mark. I'm willing to bet you, though, if we did negative 3, we'd probably get the value of 7 as well. Don't believe me, you can check yourself. I believe that negative 3 for x should be 7. Now, some things to note. In our previous example, we always found this one unique point that kind of showed us, it kind of turned the graph in a way. And it really helped create the U. Well, we still have that point right here, and it has a specific name. It's called the vertex. And this is either going to be the lowest or the highest point of your graph. Now, you need to remember, this is still a curved line. It's going to go forever in those directions. It's never going to end. A parabola does not end. However, it does have a minimum or the lowest point. So down here, our vertex is going to be the lowest point. We're never going to have a y value lower than the vertex. And if we can flip it around, if we had the U shape of the parabola going the other way, then we would never have a point higher than the vertex of that parabola. Let's take a look at another example. This one's a little bit more complicated. In fact, I actually left out a term of x. That's okay. I'm going to do the same thing before. I'm going to work with the very easy numbers. And just like before, we're going to go ahead and just plug them into the equation and see what we get. So, start off with negative 2. So y equals negative 2 parenthesis negative 2 squared minus 2. That's a lot of 2's. So, negative 2 squared becomes 4. But we have to multiply it by the negative 2 because multiplication defeats subtraction according to order of operations. So I get negative 8 minus 2, which would give us negative 10. Well, that's way off of our graph. That could be difficult later. All right, well, let's go ahead and check out negative 1. So I'm just going to separate them real quick to show they're different. So y equals negative 2. This stays because it's part of the equation up here. It doesn't go anywhere. Negative 1 squared minus 2. All right, negative 1 squared, that's just 1. But, again, we have to multiply by negative 2. So this becomes negative 2 minus 2, and that would be negative 4. So we're going to go ahead and update our table. We can actually plot that point. That one works. Negative 1, negative 4. It's all the way down here. And just like before, we've got to go through all 5 points to give us a good idea of what this graph is going to look like. Again, 0, always a great point to start with. Very easy to plug in. Usually makes things disappear. For instance, 0 squared is going to be 0. And negative 2 times 0 is 0. Hence why I like using it so much. And when we clean this up, we get negative 2. Go ahead and update the table. Now let's go ahead and plug in 1. So, y equals negative 2 times 1 squared minus 2. Well, 1 squared is still 1. Very exciting, I know. And negative 2 times 1, that's negative 2. And then we take away the negative 2, we get negative 4. It's like the values are coming back on us now. So, using the kind of prediction stuff from before, negative 1 was negative 4, and 1 was negative 4. I'm willing to bet negative 2 might just end up being negative 10. Well, I'm saying positive 2 should be negative 10. Let's see. Easiest way to find out is just do it. So, y equals negative 2 times 2 squared minus 2. Well, 2 squared is going to go and be 4. And 4 times negative 2 is negative 8. And when we clean it up, just like I predicted, we get negative 10 again. So, we have enough values to give us some sort of graph to tell us what this is going to look like. So I'm just going to go ahead and plot the points. I can't plot this point based on our graph because negative 10 is just going to end up being too low. I can plot the other 3 though. I can't plot this one again, same reason, negative 10 is just going to be too low. So 0 is at negative 2 and 1 is at negative 4. So we're going to get a graph that goes like this. Now before I was talking about the vertex. In this case, for this example, the vertex is right here and it's going to be the highest point. Now we know it's the highest point, just to help show that's an arrow. It's the highest point because, as you can tell very quickly from the graph, the parabola never goes any higher. The highest it can go is negative 2. When we talk more about domain and range, that's going to become a big factor. Thanks for watching.